Hello everyone, welcome back to our channel. Today we are back with a new interesting problem, and the problem of the day is paths from root with specified sum. So let's see the given problem statement. Given a binary tree and a sum s, print all the paths starting from the root that sums up to the given sum. Path may not end on a leaf node. So basically we will trace our binary tree until we get our target sum. And if we get a path whose sum of the values is equals to the given target sum, then we have to return that or print that path. So it is already mentioned that we have to start from the root and then keep on calculating till we get our target sum. So I hope the given problem statement is clear. Now let's see the first example given and decide how to approach this problem. So this is our tree. So at first let's discuss what are the basic needs to solve this problem. So we basically need a array list which will store the current path, and we also need a resultant array list, right? This resultant array list will store all the current paths whose value sums up to the given target sum. So basically it will be storing the array list, and current path array list will store a particular path which sums up to the target sum. Now guess what will be our base case in this given problem. So the first point is the point where we get our target sum. We will return a current path, but the base case is when we get a null. That means there are no further nodes. For example, this 20, the left child of 20 is null. There is no further node in the left side or in the right side. So in this case we will return, and this will be our base case. If the given node is equals to null, what we will do? We will simply return. So we have discussed our base case. Now let's see how we will approach to this problem. So we have to start from the root node of our tree. So the value of the root node is 1. And in the first example, the target sum was 8. So if we include this node in our current sum, so we can see the first node has a value of 1 and it is not null. So we will include this node in our current path. It might happen that if we traverse further to its left or right child, we get our desired target sum. Thus, we will include it into our current path. So if we include this node, what will be our remaining target sum? It will be 8 minus 1, that is 7. So our target sum is 7. And now we will go to the left child of our root node. The value of our left child of the root node is 20. So we will add 20 in our current path. If we add 20, the remaining sum will be 7 minus 20, that is minus 13, right? So it is minus 13, which is anyways less than our target sum. But we will not stop here. It might happen that if we travel to the left child of our current node, we may encounter our target sum. So that's why we will keep on tracing the tree. If we go to the left child of our current tree, now we got null. And as we have discussed in our base case, if we get a null node, we will return. We will simply return. So our current path will be 1 and 20, but it is not giving our desired sum, right? It is not giving 8. So we will not include in our resultant array list. And same will happen when we go to the right child of our current node. That is also null, so we will return. And thus this is our final current path, which is not giving our expected sum, so we'll not include it in our resultant array list. Now we will traverse to the right side of our root node. We get 3. So in our current path, our root node was there, and we will add the current node, which is 3. So let's check the remaining sum. When we added 1, the remaining sum was 7. Then we added 3. So the remaining sum will be 7 minus 3, that is 4. So we have to include more nodes to get our or to achieve our target sum. Thus we will traverse to the left side of our current node and we get a 4. We will add this into our current path. Now we will check the target sum. The remaining target sum was 4 and the current node value is also 4. So we got 0. That means there is no difference between the sum of all the elements in our current path and the target sum. And thus we can say we got a path which is our desired path, because the sum of all the values of the nodes is equals to the given sum. So we will add this current path in our resultant array list. So our resultant array list will store 1, 3, 4. So now we will not stop here, because it might happen that if we traverse further in our right child, we might get more such paths. So we will traverse until we covered all the nodes of the tree. So this is how we will continue with our problem. And each time we get our desired current path, we will add it into our resultant array list. But in this example, if you iterate further to the right node, you can see we will add 4 with 15, we get 19. So anyways, we can't get a desired path. And all the child nodes of 15 and 4 are positive. So we are not getting back to our target sum, which is 8 anyways. Thus we got only one path in our binary tree whose sum of values is equals to the given sum. If we add 4 plus 3 plus 1, we got 8, and our target sum was also 8. So can you guys guess how we will approach to this problem? If you have watched my previous video, it was also a similar kind of problem. You can check it out after solving this problem. There is a I button on the top of the screen. So unlike previous problem, in this problem we will approach from top to down of our given tree, and then simply we will call the child nodes, the left child and the right child of our root node recursively each time. And after each recursive call, we will check if the sum of the elements in the current path is equals to our target sum or not. During the traversal, if we got a current path whose value sums up to the given target sum, we will add that path in our resultant array list. This is all we have to do. Now let's get into the code. So we will start our program as we have discussed. That is, we have to create two array lists. One will be the resultant array list, which will store all the current paths whose sum is equals to the target sum. So this resultant array list will store a array list of integer type. Let's name it as result. Now we will take a array list which will store our current paths. So array list of integer type which will store the current path. So we are basically performing depth first search in our given problem because we are starting from our root node and then we are traversing till we are getting our target node before any backtracking. So we are performing depth first search algorithm. So let's create a method dfs, and in this method we have to pass our root node. Then we will pass our target sum. It will take the resultant path and the current path as well. And after performing DFS and calculating all the resultant path, we will simply return our resultant array list. So we can see our method, it is accepting the array list of array list. So we have returned the same, and now we have to construct this DFS method. So let's do that. This function is accepting a root node. Then we have passed the target sum. So let's take int target sum. Then we have passed the current path. So it will receive an array list of integers. Let's name it as current path only. And at last it is also accepting a resultant array list, which was array list of array list. So let's take that also. And the data type was integers, of course. Now at first, let's write our base condition as we have discussed. That is, if our node is equals to null, we will simply return. So if our node is equals to null, we will return. And else, in our current path, we will keep on adding the values of the current node. The value of the current node is node.data. It is defined in the class node. So we will simply add node.data. So after adding the current node in our current path, we have to traverse to the left child or the right child of our root node. So let's call the left child and the right child recursively. So we will call the recursive function, and in the node we will pass our left node. And what will be our target sum? It will be the given sum minus the current value. In our example, we saw that we are always subtracting the current value from the target sum. So let's subtract target sum with the current node value, that is node.data, and then we will pass array list and the resultant array list as well. So let's write the code for that as well. New array list, it will store the current path and the resultant array list of array list. So by this we have recursively called our left child of our root node, and in the problem definition we have taken the array list of result. So let's name it as result. Yeah, so now we have to recursively call the right child as well. So for that we will call the function once again. Now instead of calling the left node, we will call the right child, and the target sum will be subtracted from the right child as well, value of right child as well. So target sum minus the node dot data, and we will pass a new array list which contains the current path and the resultant array list. So basically we are creating a new array list for each new node, that is our left node or a right node, while traversing through our binary tree. And we are also copying the current path in our new array list. This is what we are doing. So we are almost done with the code. And if you notice, in each function call, we are subtracting our node data with the target sum. So if the sum of the values present in our current path is equals to our target sum, so at one point, our target sum will be equals to the current node value, which we have seen while traversing through our example, right? So when this condition occurs, that is the target sum equals to node dot data, that means we found a path whose sum of values is equals to the given target sum. In this case, we will add this current path to our resultant array list. So simply in our result array list, we will add our current path. That is also a array list. So new array list where we will pass our current path. So this is all we have to do, and every steps are discussed in detail in the first part of the video. Now let's quickly compile our code. So there is a compilation error result.oh, there is a typing mistake. Let's just quickly fix it. Now let's compile and run again. So compilation completed. Let's submit our code. So our code has passed all the possible test cases given. I hope I was able to explain this problem. And if you want to practice a similar kind of problem, you can check out the last video, which was based on a binary tree as well. But there we have used bottom to top approach. And in this problem, particularly, we have used DFS algorithm because we have started traversing our given binary tree from the root node till the depth of the tree until we found our resultant current path. So yeah, this is all about the video. And if you found anything helpful from this video, please like, share, and subscribe this channel. And let's get back tomorrow with an interesting problem. Till then, happy coding.